Okay, this first problem that we're going to continue to solve, these different word problems, you know, uh, this chapter is on the try-catch exception handling. And so yesterday we had a lab day and got more than one student that said, hey, are you going to keep doing some demonstrations? Because I kind of, I learn a little bit. So I was like, okay, we'll just keep doing these. This first one, we'll do two. We'll do two problems. Problem one is this. Write a program named subscript exception test in which you declare an array of 10 doubles and store values in the array. First one's pretty simple. Write a try block in which you place a loop that prompts a user for a subscript and displays the value of the corresponding position. Create a catch block that catches out of range and displays an appropriate error message. Now, where you're prompting the user in a loop, to me that sounds like a console program, right? It doesn't sound like a GUI. If you're prompting the user with a form, well, you're not looping that button click on the form. Instead, we're going to create a console program. So let me go ahead and add a new item. Let me right click, add a new project, and this will be a console app, ex1 console. Declare an array of 10 doubles and let's initialize those doubles. Two, three, well. Okay, so we've got an array of 10 doubles. Let's continually prompt the user for a subscript. Kind of a neat trick I haven't shown before. There's three parts to a for loop. Of course, we have the initialization of a control variable, we have the test, and we have the update. So these are the three parts as separated by semicolons. And one thing that you may know, maybe you don't, is that actually these are all optional. And so this is actually a valid for loop, a for loop with just some semicolons in between. And you might say, what in the world? What this does is create an infinite loop. It just loops infinitely, right? It's just going to loop until something stops it. In which case, we know how to break out of a loop is with the keyword break. And so, for right now, just solving this problem, I'll make an infinite loop because it says write a loop that prompts a user and displays, and eventually that loop will stop, and we'll stop it one way or another. Enter a position in the array, and I'll show you the value. Now, if you run this, let's run the console. Let's run the right hotkey. So if I were to say position 0, we need to say my numbers sub index. And that will get the data out of the array. So if I say position 0, we get 1.1. If we say 1, 2, 2, keep on climbing, we know that there are 0 through 9, those are the indexes. So if I do an off by 1 error, which is pretty common, I say, okay, position 10, there is no position 10, we get an exception. This is a very common exception. You've all seen this before. This is index out of range exception. This is crashing the program. And so this is a very simple first problem to solve, because, you know, it's like basically, again, this is a built-in exception. How do we catch that? Well, this line 8, is the culprit. We know that it is ultimately line 8 that we need to then wrap in a try block. And this is going to be an index out of range exception, EX. So we're going to catch the exception. And what do we do here? Well, maybe we just say that is an invalid index. Please enter a valid position of 0 through 9, period. All right, we give a friendly error message. Now notice I'm catching this and I'm calling my identifier EX, and I'm not even using EX, and that's fine. You get a little green squiggly that says, hey, you're never even using it, in which case you could just delete it since you're not using it, but you're still going to catch your exception. Now if I traverse this again and I jump ahead and I say 10, well, now we just get that is an invalid index. Please enter a valid position, and we can continue on. And now, instead of crashing the program when you have an invalid index, now we just have an error message. What have we just done? Data validation. We just validated our data using a try-catch block. Okay, so again, the culprit, line 10. The solution, wrap it in a try-catch block, keep it running. This is an infinite loop, it just keeps looping, because really our program doesn't need to stop, I guess, we just let it go. So that is the first problem. Second problem. Okay. Argument exception is an existing class that derives as a child, aka from exception. You use it when one or more method arguments do not fall within a range. Create an application named swimming water temperature with a variable that can hold a temperature expressed in Fahrenheit. Within the class, create a method that accepts a parameter for water temp and returns true or false, indicating whether water temperature is between 75 and 80, and thus comfortable for swimming. You ever swim in 70-degree water? Ooh, I don't know. Seems cold. Continuing on. If the temperature is not between 32 and 212, thus freezing and boiling, it is invalid, and the method should throw an argument exception. In the main, continuously prompt the user for the data temperature, pass it to the method, and then display a message indicating whether the temperature is comfortable, not comfortable, or invalid. So again, here's kind of a interesting thing to take note of. The main method is the method that all programs start, like it's the first line of code in all of our apps that we've built. Now, in many cases, we don't code the main method, but I think of the main method as the start line of a race. Like when your program starts, it starts at the main method. You just don't see it because in the GUIs that we're making, that's all abstracted from us. We don't, it's kind of the code that we don't see. And even nowadays, in the console apps that we code, they don't even show us the main method in the console apps. In like 5 years ago, that was not the case. But what I'm going to do is I'm going to make this, because of this language right here, I'm going to make this a console app, not a GUI. And again, continuously prompt the user for data temperature, kind of using the same logic as we just keep asking the user a question in a console. So let's make this. This is argument exception. It's built in. When an argument, so you're going to have a method parameter, and if it's not within a range, we're going to throw an argument exception. Create an application called swimming containing a variable, the hold temperature, degree, and Fahrenheit within the class. Okay, so let's spin this up and piece it together. So we're going to say add a new project. This is going to be a console app. And they do say within the class, create a method for water temperature and returns true or false. So I need a class, add a class. Classes are I don't know, classes are typically nouns, people, places, or things. This seems a temperature of water seems like an attribute, so I'll just call my class water, and then water temperature will be the attribute. So I'll make my public class water, and the variable can hold a temperature expressed in degrees Fahrenheit, swimming water temperature. So private, wanted a constructor, private integer seems like whole numbers. I guess we could make it have a decimal point if we wanted to, underscore swimming water temp, and public int will make property that gets and sets our instance field. So again, we've got an instance field, and we've got a property that can modify our instance field. This is the idea, again, going back to object-oriented principles of data hiding. We're hiding our instance field behind a public property. Okay, so this is one of those pillars of object-oriented. You don't allow direct access. Instead, you control access through properties and methods. Okay, so that's important. We've got, what is this called? This is called our default constructor. Okay, you kind of get that for free if you don't code it. The compiler will put it in your code for you. You don't have to code it. But if you overload the constructor, you no longer get that for free. You have to code it. Okay. Create a variable that can hold temperature in Fahrenheit. Within the class, create a method that accepts a parameter for water temperature and returns true or false, indicating whether the water temperature is between this and that, and thus comfortable for swimming. So the method has to do with is comfortable. Is comfortable is a convention, right? A method that returns a Boolean, you start that method with the word is. Makes sense. It is or it is not, right? So I'm going to make my method public bool, returns bool, capital IS comfortable. And it accepts the temperature. Now, again, this is going to return true or false. So very simply, if it's between 75 and 85, we return true. So if swimming water temp greater than, I keep forgetting my numbers, greater than or equal to 70, greater than or equal to 70, and swimming water temp less than or equal to 85, return true, else return false. And now, one thing that's worth noting here, when you have something like an if-else inside of a method, the rule that you'll find out really quickly is that all code paths, in other words, you have different branches. When you have if-else statements, your code can take different paths. All code paths must return a value, right? So if this is true, else this is false, you've got two code paths, they both return a value. But in other words, every way through the forest, every way through the branching, they all have to return a value. So we're doing that because some chance it's true, some chance it's false, we're returning true or false through all code paths. If the temperature is not between 32 and 212 and is invalid, the method should throw an argument exception. Now, that's kind of more extreme, right? So this is 75 and 85, those are within bounds. So before I check for this, I would check for the even more out of bounds, right? So before this returns true or false, I'm going to check for these extreme values of 32 and 212. So if swimming water temp is not between 32. So it needs to be less than 32, or swimming water temp greater than 212, throw argument exception. And you can, I believe, throw new argument exception. So what this is going to do is kind of say, hey, the argument that was passed in is out of an expected range. That's exactly what this says. You use it when one or more method arguments do not fall within an expected range. So here's our argument. It does not fall within an expected range. Throw this water is either boiling or freezing. Okay, now what's interesting around this chunk of code is that we're not going to catch that exception inside of this is comfortable method. The exception fires there, right? That's the language that they use. The exception is triggered or the exception is fired. In other words, the exception occurs. It can occur here. Okay, but we're not going to catch it here. Instead, the idea is that, hey, I made this class. Someone else, bless you, on my team might be implementing this class, or might actually be a user of this class. And so back in my program, I could do something like water lake water equals new water, and then I could say swimming water temp equals 80. So I set this swimming water temp, and then I'll do a console.writeLine. I think it wants a loop. Lake water dot is comfortable, and we're going to pass in lake water dot swimming water temp. So we set the swimming water temp, and then we're just going to send that into the is comfortable method, and keep in mind is comfortable is going to return true or false, right? So the temp is 80. If I run this swimming water demo, we get the output is true. Our 80 is comfortable. And if I go below the 70, I think, like the 56, and I run it, you can see it returns false. If I then make it freezing, like 30, we actually get an unhandled exception and it crashes the program. Why would you intentionally crash your program? Again, I think it boils down to it is a condition that you as the software developer or whomever, you really just don't want to allow certain conditions to happen. You don't want to allow the rocket to exceed a certain temperature, because if that rocket exceeds a certain temperature, it blows up. It is a red flag. You're raising the red flag in your software. You don't want the rocket to blow up. You're going to lose millions and billions of dollars, right? So instead of just putting it inside of like an if statement and trying to loop it, you're going to raise some red flags. So like this is intentionally crashing your software. This is raising the red flag. We're not letting the rocket blow up. Okay, instead, we're going to force the developer to handle this situation, because if they implement our rocket class and the temperature goes out of range, we're going to notify them that is a problem, and they're going to have to address that in the software somehow, right? And so now we know that, hey, this is not an acceptable condition. It's a bad thing to happen. Right? You don't handle every situation like this. This is raising the red flag. This is pointing out a severe problem in your software. Okay, that's kind of the idea. This is an exception. It's not something that happens every day. It's occurring exceptionally, rare things, right? That are big problems, that are problems in your software. You might choose to throw an exception, and then, therefore, you're either crashing the software or you're forcing them to implement some sort of solution. Okay, so what solution are we taking in this case? Well, we're just going to wrap this in a try catch. Now, and argument exception EX, and I'll do a console write line EX.message. Now, the message in this case is the water is either boiling or freezing. You saw where I put that message, right? I put that message right here. So the message property was configured in this string when I threw this argument exception. Now, this particular demonstration I think is going to be useful for you guys, because you're doing a lot of this in your labs where you're throwing exceptions in one place and that exception bubbles up, right? What means by bubbles up is if you don't have a catch for the exception in this method, it bubbles up to the calling method. Well, what is the calling method? The calling method in this case is the main method. You don't see it here, but the main method is calling is comfortable. And what happens if an exception never gets caught is that it crashes your program. So it can only bubble up so high, and if the exception bubbles up and the main method does not catch the exception, that's when it crashes your program. Right? So there's the theory behind that. Now, it says this problem says continuously prompt the user. Again, if I just want to continuously prompt the user, I can do this little for loop trick. And I'll do something like this. I'll put all of this in my loop. And I'll say console write line, give me a water temp. I'm going to be demanding this morning. Put it in an exclamation. Console, wait a minute, int water temp equals convert to int32 console read line, and then pass in water temp right here. So I'll instantiate my thing here, lake water, okay, and now it's a continuous prompt. I could say 10 degrees, I could say 50, I could say 90, 100, 200, not temperature, or not comfortable, not comfortable, not comfortable. And if I say 300, either, and we don't have a way of breaking out of this, but that's, throw a break in there somewhere if you so choose. And that is the second problem. We're going kind of fast today, so maybe a third. Let's take a look. Create a program named find square root that finds the square root of the user's input value. The math class contains a static square root that accepts a double and returns the parameter square root. If the user's entry cannot be converted to a double, display an appropriate error message and set the square root value to 0. Otherwise, test the input number's value. If it's negative, throw an application exception. And when you say negative numbers can't be negative, and again set it to 0. If the input value is double and not negative, pass it to the square root. Okay. So doesn't talk about continuously prompting, so I'll just go back to maybe a GUI here. Add new project, form, square root demo. Find square root. And get a text box. For the number. Text. We'll just call it text number. It wants a double, I think. If the user's entry cannot be converted to a double, display an appropriate message and set the square root to 0. So I'm going to use try parse for that. Double user input equals and then I will say double dot try parse. The first input is the string, so I'll say text number dot text out user input. So the way this is going to work is it'll convert it to a double if it can. Otherwise, it should set user input to 0, and that will be that first requirement. Now in my label, call this label result. So I'll say if, now here's the deal. You can also, try parse is a pretty awesome method because it does a couple things. The first thing it's going to do is try to convert a string into a double, and based on if it can do that, it puts different values into that double. It also returns true or false, so you can actually wrap it in a big if statement. And if it works, then the conversion worked, else conversion didn't work. Let's put that in some quotes. And conversion worked, otherwise conversion didn't work. And say label result.text, please enter a valid number. And let's run that. We haven't done anything with counsel or anything with exceptions yet. So if I put in like the letter A, it says please enter a valid number. If I put in like 12 at, please enter a valid number. And so if the user's entry cannot be converted to a double, display an error message and set the square root to value to 0. And so label results.text the square root value is user input, and that should say 0. So if I say A, the square root value is 0. Because that's what try parse does. If it can't convert it, it sets that variable to 0. And so otherwise, test, okay, so otherwise we did convert it, test the value. If it's negative, throw an application exception, which you pass the message number can't be negative. So now it works. So now we test it for a positive number, right? If user input is less than 0, it's a negative number, right? Throw new argument exception and say number can't be negative. Number can't be negative. And again, set the square root to 0. So I'll kind of do a manual user input I'll make a square root here, square root equals 0. So just very manually, number can't be negative. The square root value is SQRT. And so now, if we run it, we give it a negative number. Number can't be negative, the square root value is 0. So we're throwing an exception. We're not yet handling that exception. But we are throwing it, which is part of what it's telling us to do. If the input value is double and not negative, pass it to the square root method and display the return value. So finally, in this else, this means that not negative and can be and is a double. So I'll say square root equals math.square root user input. And let's assign the square root to string. The square root of your input is SQRT. So if we just do a simple number like 25, the square root of your input is 5. My math brain is failing me right now. 49 is 7. 9 is 3. 100 is 10. So it's finding the square root. Let's just throw in some odd numbers. Obviously, we're not getting nice and clean numbers, but it is working. Now, doesn't really talk about how to catch anything here, but it's breaking the program, and maybe we don't catch it. You know, it's really not part of the solution is to do the catch. So there we go. Went through some problem solving. Hopefully you caught something in there that helped you do your labs. Any questions? All right, let's get to work on some labs.